Welcome to Solving Equations with Square Roots. The first thing we need to think about, of course, is our order of operations. So if you recall, our order of operations going forward is GEMDAS. So we start with our grouping symbols, our exponents, our multiplication, division, adding, and subtraction. And of course, that means when we're solving equations, we're using the inverse operations, which means I'm going to do this all backwards, right? Sad Meg. Now, we have talked about all of these, subtraction, addition, division, multiplication, and grouping symbols before. What we have not talked about yet is what to do when there's an exponent. Well, the opposite operation of an exponent, as we've talked about in previous lessons, is a root. Okay, the opposite of a radical is an exponent, which means the opposite of an exponent is a radical or a root. Okay, so if I have a square, a number to the power of 2, right? So 15 to the power of 2. To get rid of that exponent of 2, I would take the square root. And those would cancel each other out, and I'd be left with 15. Okay? So let's apply that to some equations. So firstly, I have x squared equals 144. So this is a one-step equation. And what I'm going to do is I am going to draw my wall so I can clearly see the two sides. Now I want to get x by itself. X squared is the same as saying x times x. So I need to know what number times itself is equal to 144. Now there are two possible answers here, but we're going to focus on the positive one first, okay? And to get this answer, what we're going to do is we're going to take the square root. I'm going to think about that, what number times itself equals 144. So I'm going to use that square root symbol. And of course, just like any equation, if I do it to one side, I have to do the same thing to the other side. So x is alone because the opposite of an exponent is a root, okay? And then I have the square root of 144. There are two possible answers here. One is 12. 12 times 12 equals 144. And negative 12 times negative 12, because a negative times a negative is a positive, also gives me 144. So my answer is positive or negative 12. You can also write that as 12 comma negative 12. However you wish to write it, those are all correct answers. If you put x equals 12 and it was only asking for one answer, then that is probably right, but we do need to acknowledge that the negative is an option there. Go ahead and give it a shot. Pause the video. Figure out what x squared equals 289. What is x? Don't forget to continue the video after this. There are a few more problems. All right, next we have x squared equals 45. So this one's a little bit tricky, not because of figuring out the operation, because hopefully you've practiced by now. You know that we're going to find the square root on both sides. The trick here is that the square root of 45 is not a perfect square. So in this case, I need to approximate my root, which we did practice in a previous lesson, okay? So we have a couple ways of writing our answer here. I can literally write x equals the square root of 45. I can write the simplified form, because 45 is the same thing as saying 9 times 5. And the square root of 9 is 3, and I still have the square root of 5 inside, so I can simplify, right? So I can leave it like the square root of 45. I can simplify my answer with that prime factorization. Or, and ideally this is what we would do, I can also approximate it. So if you recall, when we approximate square roots that are not perfect squares, I consider what is on either side of 45 that's a perfect square. Well, below, or let's go with the closer one. Square root of 49 is above, that's 7. Or the square root of 36 is below, and that's 6. So the answer is going to be 6 and some change. 45 is pretty close to 49, so I'm guessing this is going to be more than 6.5, but obviously less than 6.9. So to get a more accurate answer, I'm going to make a little fraction here and kind of sort this out. So I have 36 and I have 49. So my denominator is going to be the difference between the largest and the smallest. So 36 and 49, the difference is 13. And then I'm going to think about what the middle and the smallest difference is. 36 and 45, that's 9, okay? So 9 over 13, that'll give us approximately, well, let's see. How many times does 13 go into 9? It doesn't, which makes sense. We don't want it to go into 9 because that would mean we did something wrong. So 13 into 90, well, I know that 10 times 9 would give me 90. So obviously it's smaller than that. I'm going to start with, say, 7, okay? 13 times 7. Hey, I already have the 7 here, even better. 13 times 7, 7 times 3 gives me 21. 7 times 2 plus 2, 91, that's a little too big. So obviously it's going to be 6. So I'm not even going to continue here because I just want one decimal place. So approximately 6.6 is also an option. So there are 3 possible options here to write this out. Square root of 45, 3 times the square root of 5, or approximately 6.6. Continuing on, we do have a 2-step equation now. So when we get to solving Pythagorean theorem, you will have situations like what you're looking at here where you need to move another term, a constant term, before you can actually do your square root. So remember, we're doing inverse operations. That means that we are going to get rid of any addition and subtraction or multiplication division before we get to our exponent. It's really crucial that we get rid of that 4 before we take the square root. Okay, so I'm going to subtract 4 from both sides, just like I would for any equation. I still have on the left side here that x squared. 4 minus 4 cancels out. 20 minus 4 gives me 16. Now this is pretty simple. I am going to take the square root on both sides. X is alone, and my answer is now either positive 4 or negative 4, depending on what we're working with, especially if it's Pythagorean theorem. Positive 4 is probably what you're going with, but these are both answers, so make sure you are aware of that. Go ahead and try it yourself. And remember to continue the video. There is one more example and a couple more you tries after this one. All right, last example before you try a couple more and wrap up the lesson. So again, I'm going to draw my wall. And here we are going to use our inverse order as well. And remember, division and multiplication comes before exponents. So yes, I have that exponent, but this is 16 times x to the power of 2. 16 is not being squared. It's not parentheses there, so we are not going to treat 16 as if it is being squared. What I'm going to do is I'm going to divide both sides by 16 to get x as isolated as possible before I take that square root. So I have x squared still remaining, right? Because 16 divided by 16 cancels that out. Now 9 over 16 cannot be simplified. I did that on purpose. Because when I take a square root of a fraction, we haven't looked at examples like this in previous lessons, but it's actually pretty simple once you get the hang of it. So we have x squared, the square root cancels that out, x is alone. Now when you take the square root of a fraction, you are going to take the square root of the numerator over the square root of the denominator. So you should end up with another fraction. And because 9 and 16 are both perfect squares, it should make it really simple, right? The square root of 9 is 3, and the square root of 16 is 4. So I need to erase that radical there. Whoops. I get 3 over 4, or negative 3 over 4. And I can prove that this is accurate by saying 3 over 4 times 3 over 4, right? 3 times 3 is 9. 4 times 4 is 16. Can't be simplified. That gets me back to my original, where I was originally squaring x. Okay? 2 more for you to try. There are no more after this, so go ahead and pause the video, get these done, get them checked, and then go ahead and practice some more problems. Have fun.